Hey guys, welcome back. I'm just going to do a register, so if you haven't already, please could you comment something so I can see who we've got. Hopefully you guys had a nice Easter break. All right, so who have we got? Jay. There we go. Cool. Lucy, Nuala, Elliot, Harry. Yeah. Billy. Yeah, the list isn't alphabetical, so it's not ideal. Chloe, George, Louis, Ollie, Guy, Tristan, Becky, Scott, Jake, Danny, Callum. Cool. So I'm missing Kieran, Lucas, Isaac, and Tom. All right. If you guys are there or turn up in a minute, just click attending. I don't know if you guys missed lectures before Easter. They're all up on YouTube, so you'll be able to catch up on those. All right. So yeah, today we're going to be looking at probability. Um, yeah, I've got a few notices to give out to you guys though. So we got the test is not this week, not next week, but the week after. So that's the week beginning the 27th. So you've got from the 27th till the 29th to do the test. And that's the kind of important test that you were going to do in the sports hall at college, but now you're going to be doing at home. Please try and do that under exam conditions and in the correct amount of time. But yeah, it's right. I'll trust you guys to do that. What you need to do then is email me photos or scans of your answer booklet. So the whole thing will be uploaded to Moodle on the 27th for you guys to download at 9 a.m. It needs to be handed in by the end of the day on the 29th, and then your lecturers will mark it on the 30th and the 31st. So yeah, Monday to Wednesday you guys are doing the tests, and then Thursday to Friday we're marking them. So that's one thing, is the test is coming. How long is it if you get extra time? So the test is 2 hours. You get 25% extra time, so you'll have 2.5 hours if you get extra time. Yeah, so that's test wise. I would prefer if you guys printed it and wrote on the test, but because it is quite a lot of pages, I'll accept anything. Um, I know it's a hard situation to be doing tests in, so if you can print it, write on the test. Excellent. There's space for you to write. If you can't print it, do it on some A4 and scan it. Will anyone know if it took longer? No. So you could, yeah. To be honest, if you take longer than 2 hours, it's not the end of the world. I would rather you try and do it in exam time so it's more accurate. Um, yeah, and I would rather you didn't do it with your notes. It should be a closed book, proper exam. But yeah, so just try and do it authentically because we want to get a good idea of where you guys are. Okay, next thing is assignments and progress checks. I'm just going to go on to Moodle quickly. To show you guys how to do this. Cool. So if you log yourselves into Moodle, if you then go to My Courses, A2 Maths. Now the mock exam you guys have to do will be up the top here. So it'll probably be right at the very top of the page so that nobody can miss it. So that's where the mock will be. If you scroll down, so I think assignments wise, I think we got up to 20. I can't remember. I had this written down earlier. It's 24 or 25. If you click on week 24, there is now this new skills check and assignment upload. So if you guys could click on that. And you can say some instructions here. Please do the following. Upload any assignment questions you have and complete the skills check, writing your answers in the boxes provided. So if we do this and give it a go, it has the skills check there on the screen. It then has some more instructions here. Don't write in this box. Upload the assignment questions you got stuck, or a photo of the assignment to prove you did it, and upload your workings for the skills checks. So it requires you to upload 2 files. So here you go onto this menu and you can choose files to upload. So I'd like you to upload 1 photo for the assignment, 1 photo for the skills checks, minimum. If you want to upload more than that because you need help, do. And then you've got the questions from the skills check are asked down here instead. So you type it in, hit enter. It will mark some of it for you. Obviously, this one here is a bit broken. I need to fix that. But yeah, so some of these questions it will mark for you, which is really good. Some of them it will mark for you and get it wrong, but it doesn't matter because I will be checking through all your answers anyway to see how you guys got them. So you, yeah, I think that's all good now. Confirm. Yes, I want the question to be saved. Yeah, so you guys will be able to type in your answers. I'll do it quickly. So I need to upload 2 files. Let's take a photo. Great photo. Let's upload that. There you go. And I think I need to upload a second file. So let's take another photo, choose file, take a photo. Here's some work I did earlier. So you guys will photograph your skills checks and assignment. Use photo, upload file. Rename, because there you go. So you've got your 2 files there. Then you're going to answer the questions. How do I do a systematic sample? I'm not going to tell you guys because you might need to answer this one. So blah, 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 just to do a test. Midpoints of each group, I don't know, 5, 4, 5, 6, 7, I don't know, whatever. Calculate the mean, I don't remember what it is, 2.42 maybe, and standard deviation 12. Okay, so again, it's all the questions. I'm just making rubbish up now. There we go, cool. Right, hit next. It will then say, are you sure you want to do this? So you go submit all. And it will say, okay, it'll say this one's not yet graded because I need to mark this one for you, but I can now see your answers. All these answers, it will tell you if it's wrong. It'll give you some hints sometimes. It might give you the correct answers like it does here. And then it'll give you guys a chance to redo it. So if you click finish review, you can then do the quiz again. And that's how we're going to be checking your assignments now. So if you guys could do those, I think we're up to week 27 maybe, but you'll see them starting to pop up. I mean, this is what we're doing this week. You'll see the skills checks and assignments there. So if you guys could be doing those, I will be checking them. And also, I know last week we had the over Easter I set you that work to do the what was it called? The large data set analysis task. This one. Could you guys make sure you've done that? I've checked. A few people have done those already. Could you all make sure you're uploading that? I'll give you till the end of this week if you need it, but I do want to see that one being finished off and uploaded. Cool. All right. So next week we're going to be revising for the test. For this week, though, we're going to get on with probability, which is the next topic of statistics. So please stop me if you've got any questions today. So what I want you guys to do first of all is to decide what you think probability is. So have a think and write your answer as a comment. Here's some keywords that you might want to think about. We're going to describe all these keywords in a minute, but I'm going to give you guys, I think, 3 minutes to have a think about what is probability and come up with a definition for me. Cool. Right, timer starts now. Give it a go. Right, still waiting for some comments, guys. I'll give you 1 more minute. See if you can give me a definition for probability. Doesn't matter if it's wrong, just give me something to work with. So 1 more minute. Cool, there's some responses. Everyone get something in. Thank you for those of you who have replied already. That's really good. Okay, what have we got? So we got the likelihood of a predicted outcome. Cool. We got probability is the chance an event happens between multiple other outcomes. Okay. The chance of a specific outcome coming from a set operation or event status samples. That sounds like a definition you found somewhere, Louis, but okay. Billy, how likely that a certain event is going to occur? Chance of getting a certain answer. Cool. Likelihood of an event from impossible certain. Cool. Likelihood of an event to occur. Likelihood of an event to occur. Likelihood of outcome happening. Something happening. Ooh, experiment to predict the outcome of an event. Cool. Nice. Okay. So I'm going to define these words first, and then we're going to string it all together. So first of all, we got an experiment, which is let's say a test. Ooh, with, that's not what I wanted, with a set number of outcomes. For event, then, we're going to say an event is a group of one or more outcomes that will happen. So a group, make that blue as well. One or more outcomes. Yeah, so we said Elliot said, oh, sorry, that was your probability definition, wasn't it? So yeah, experiment. It's got to be a repeatable process, but it gives rise to a number of outcomes. So a test of a set number of outcomes. Event is a collection or group of one or more outcomes. The sample space is the set of all possible outcomes. So set of all possible outcomes. Your outcome is what happens in the experiment. I don't think we need to define that one. Yeah, and then we've got certain and impossible. So all I'm going to change here is make it a reproducible test. So experiment is a reproducible test. Cool. Yeah. So outcome is a possible result of an experiment. So when we've done the experiment, the outcome is what you get. After, yeah, we'll define it as well. Then go on, Jake. So outcome is a possible result of an experiment. Cool. All right. So and then we got certain, which is when you are 100% sure of the outcome. So 100% sure the outcome is then certain, so it will happen. And impossible is when the event can't happen. So, or the outcome can happen. The event slash will not be the outcome. Okay. So that's a brief summary of the kind of terms we're going to be using. So probability Sorry, just make some space. So we'll be more specific. We'll say probability of event A is number of outcomes with event A divided by the total sample space. So that's how I want you guys to think of probability. The probability of something happening, probability of event A, is the number of outcomes with event A out of the total sample space. If you always think about it like this, you should always have an idea of how to kind of approach probability. If you know what the sample space is, it's then very easy to work out different probabilities. Cool. All right, so we're going to try some of these, but I want you to, I know you've done probability before and you think of it as a fraction, but really try and think of it in these kind of terms. The way we kind of notate this, my mic is popping. I don't know if I can fix that. It is though, I can hear that myself. Already got limiter on. I could turn down the gain, I guess. But then I'll be quieter. But I guess that's all I can do, really. How's that? Is that any better? Is that really quiet now? Let me know if that's too quiet. But I have turned down the gain. I don't have a pop shield. Maybe that this is better. Maybe if I put the mic up a bit, you can. Hello? Is that any better? Let me know. Anyway. Yeah, so the way we notate this is probability of event A, we say it's to P brackets A. And the number of outcomes of event A, we could say that is N. Out of, I guess, N for the total number of outcomes. But yeah, we're going to give this a go. So I want you guys to think of finding the probability of rolling a 6 and drawing a picture card out of a deck of 52 cards. So if you guys do that, I'll give you 2 minutes to have a think about what those probabilities might be. And you might have done this back in GCSE, but try and link it to what we were just saying about sample spaces and events. Cool, give that a go. Cool. Right. Please type in your answers, but we'll have a think about this. So rolling a 6. How many outcomes are there on a dice? Well, you get 1, 2, 3, 4, 5, or 6. So the total number of outcomes, so probability of a 6, there are 6 outcomes in our sample space. How many sixes are there on a dice? One. So there is one event where we get a six out of six total events. And I know this is kind of obvious stuff, but if we start talking about it in these kind of terms, um, it'll get you better at probability. Okay, drawing a pitch card. Well, so probability pitch card. So let's think about our sample space. How many cards are there in a deck of cards? 52. How many of them are pitch cards? Well, a pitch card is a jack, a queen, or a king. So we've got jack, queen, king, and there are four suits. So we got four suits of jack, queen, king. So there are 12 pitch cards in total. So the probability of drawing a pitch card is going to be 12 out of 52, which I think would actually be simplifies down to brain's not working. 12 out of 52. Does that simplify? It's 52. Yeah, 52 will have to 26, which would be 13. Yeah, 3 out of 13 as you guys said. Cool. Right, we can give probabilities as decimals or as fractions, never percentages. Percentages are not probabilities. Cool. Everyone okay with that? But it's that way of thinking. How many outcomes out of the sample space? Okay, it does get harder, but keep thinking about it in terms of sample spaces. Next one. Flipping a head and rolling an even number. Let's have a think about what the sample space is for this one. What's the probability of that happening? Give you guys a couple minutes to try that one. So 2 minutes on the clock. Give it a go. I'll be right back, guys. Just got someone knocking at the door. It's okay. My housemate has gone for me. So most of you got a quarter for this. Make sure you know why, but we'll go through it in a sec. Okay, so we need to really for this one we need to write out what the sample space is. So for our coin, we could get heads or we could get tails. So what I'm doing now is called a sample space diagram. Rolling an even number. Well, what numbers are there? We need to write them all out. There's 1, 2, 3, 4, 5, or 6. So this is our dice. Okay, so how many outcomes are there in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be out of 12. How many of these do we get a head and an even number? 1, 2, 3. So we get 3 out of 12. Which, as you guys said, was 1/4. But you need to think about it in those terms. So don't ever be afraid to just write out the sample space. Normally as a grid, it's quite useful. And just physically count them all up. Count up total sample space, the total outcomes where this happens, and write it down. Cool. Right, so that's the basics of probability. Think about it in terms of sample space and outcomes, and it should be a lot easier. We need to be able to represent probability though, and there's two ways we do that at A level. One way is tree diagrams, and the other way is a Venn diagram. So we're going to see what you guys can do with tree diagrams. We're pretty good for time today, so let's say 4 minutes. Let's see what you guys can do. See if you can get the answers right for this one, and we'll go through it a sec because I think tree diagrams are stuff that you guys did at GCSE anyway. So 4 minutes on the clock starting now. Cool. Right, several pretty good answers for this one. Let's have a look though. So we'll go through how you meant to do these, because yeah, although they're done at GCSE, they can be quite tricky, I suppose. All right. So, tree diagrams. Let's make some space here first of all. So they're a really nice way of showing outcomes that kind of depend on previous outcomes. So, bag contains 7 green beads, 5 blue beads. A bead is taken from the bag at random and not replaced. A second bead is then taken. So, we've got 2 branches to our tree diagram. We're going to have the first choice, and then we're going to have a second choice. Cool. And it's up to you guys how you do these. I normally write the probabilities on the branches and what's happened at the end of each branch. So we've got green beads and blue beads. So I'm going to use G for green. So you could pick green and green. You could pick green and blue. You could pick blue and green. Or you could pick blue and blue. So these really are all of our outcomes. Okay, on the branches then is where we put the probabilities of each thing happening. So the bag contains 7 green and 5 blue. Okay, so that's 12 beads in total. So for the first choice, out of 12, to choose a green one, you got a 7 in 12 choice. So therefore, to choose a blue one, you got a 5 in 12 choice. Okay, bead is taken out. It's not replaced. So now there's only 11 beads. So each of these end probabilities are going to be out of 11. For green, well, we've already taken 1 green, so now we've got 6 left. For blue, we still have all 5 for this choice here, so you got 5 out of 11. For green here, well, we haven't taken 1, so we've still got 7. And for blue here, we've taken 1, so we've got 4 left. So those are our probabilities. And the rule for tree diagrams is you multiply along branches, and you add between branches. And that's the only thing really here to remember. So multiply along, add between. Okay, so find the probability both beads are green. So that's going to be, if I just highlight the whole thing, that's going to be this kind of pathway here. So we're going to have 7 over 12s and then 6 out of 11. So we need to times those two things together. So part A, 7 out of 12 times 6 out of 11, and we'll do that on the calculator. Which gives us 7 over 22. Or 0.318 something. So yeah, I'd leave this one as a fraction because it is more exact to do that. Part B, the beads are different colours. Well, there's 2 chances there. We could have this thing happening, or we could have this thing happening. So we're going to work out the top branch, timesing them together, and we're going to add that to the second branch, timesing those together. So if I make a bit of space up here, so part B, we get 7/12 times 5/11 plus 5/12 times 7/11. And again, we'll do that on the calculator. 7 over 12 times 5 over 11 plus 5 over 12 times 7 over 11. You should get 35 out of 66. Which is 0.53. So let's have a look. Harry, I think you got that one right. Your answer is double mine, isn't it? There, 66 times 2, 132. Yeah. Cool, good. Rest of you, not sure though. Scott and Billy, yours don't look quite right. So just make sure you're happy with the workings up here. So we times along the branches, then add between those branches to get 35 over 66, which is 0.5303. Cool. Any questions if you guys ask them now? We're going to move on to another one of these though. Okay, could you guys try this one? So same idea really. Maybe slightly less complicated this time. So I'll give you guys again 4 minutes to try and do this one. Can't see the. Ah, what? How do I do that? Sorry guys, I'll resize this. Right, give you another minute for that because that was my bad. Cool. Cool, looking good, guys. Cool. Right, sorry about the it not showing up when I changed the view there. So let's go through this one. So we've got probability Charlie takes the bus is 0.4. If he doesn't, he walks. Cool. Okay. So again, we've got kind of two sets of branches. We've got bus, and we've got walk. If he's late and takes the bus, so we go for L there, and not late, late, not late. So when we put a dash on the letter like I've done there, L dash, that means not. So late, not. It just saves space writing rather than writing anything up. So probability he takes the bus is 0.4. Therefore, the probability he walks is 0.6. If he takes the bus, probability he's late is 0.2. So not late there would be 0.8. And if he walks, he probability is late is 0.3. So we're getting 0.7. Cool, so there's our tree diagram. Find the probability that Charlie is late. So there's two outcomes where he could be late. There's this outcome and there's this outcome. So we want to find those two probabilities. So it's going to be 0.4 times 0.2 plus 0.6 times 0.3. Be careful your brackets, sometimes it can affect these. And should get 0.26 as most of you did. Yep, Scott, that's good as well. Yeah, awesome. Excellent, guys. Well done. So yeah, that's basically it for tree diagrams. Just remember those two rules: multiply along the branches, add between the branches. Okay. Next up, then we're going to start looking at Venn diagrams. Cool. I always start this topic by asking you guys some weird personal details. So I want you to have a quick think and decide: can you flare your nostrils? I can't. So have a think. Can you flare your nostrils? Can you wiggle your ears? I also can. And can you roll your tongue? Some of you will be able to do all three. What I'd like you all to do is to comment with N, E, or T, or any combination of those. So if you can do nostrils and tongue, do NT. See what you guys can do. And we're going to turn all this information into a Venn diagram. So I need to comment for nothing there as well. So none. Cool. So if you guys could comment these, we're not going to normally everybody's in. And we'll try and put all this into a Venn diagram. There's 19 of you, so there should be 19 sets of responses here. So start Becky. Becky was NT. I'm gonna need a better table I've just worked out. So while you guys have a think, let's write this down better. So we got all three. Then we got NE, NT, TE, NET, and none. Cool. All right, I think that's all of you guys responded now. So stop. So the way we're going to fill this out, because we've got to make sure Venn diagrams overlap. So we need to make sure we, in detail, get everything done. So Becky NT. So I'm going to put a tick in the NT column, but also tick in the N column and tick in the T column because you need to be able to do all three of those things. Okay, Jake, nothing. That's cool. So nothing there. Harry, just T. So we're going to put a dash in the T column. Ollie, N and T. So that's NT and N and T. J, NET. So all of them. So all three. That one, that one, that one, that one, that one, that one. So we take all the columns. Lucy T. So that gives me there. Billy T. Chloe T. Nuala T. George NT. Danny T. Elliot NT. Wow, loads of NTs. Louis NT. Tristan NT. Guy, all three. And Scott NT. Wow, okay. Good, nice set of data there. Excellent. Okay, so we want to try and put this, let's add up these tallies first of all. So we got 2, 2, 9, 2, 9, 2, 15, 1. Okay, so that's the data we need to put into our Venn diagram. I'm just going to write that down because otherwise I feel we will lose it. Okay, so we're going to put this into a Venn diagram. So let's get rid of all this. Cool. All right. So we're going to need 3 circles, and they need to overlap each other. We're going to label these N, E, yep, N, E, and T. And then we're going to add you guys up and put you into the relevant bits. So people that could do all of them was 2. Good. People that do N and T was 9. So we've already got 2 people. Basically, we always start these by filling in the center outwards. So there are 2 people. I might just put the list back up actually, just so you guys can see. So all was 2. NE was 2. NT was 9. TE was 2. N was 9. E was 2. T was 15. None was 1. Cool. So we started off in the middle. So this is people that can do all of it. So that was 2 of you. Okay, now we're going to move out and do NE. So N and E is this bit here, and there should be 2 people in here. But we've already got those 2 people. There's 2 people in total. The NE region, if you like, is this region here. This shape here. This is NE. And there's already 2 people in there. So we don't need to put any more people that can flare their nostrils and wiggle their ears. And we've got those 2. Those are 2 people that can do everything. So they've already been included. There are no people that could do nostrils and ears. NET. So that's why. Okay, so we've done the top column, we've done that column. We're now going to move out to the NT column, so there should be 9 people in total. NT would be all of this bit. So we need 9 in there in total. Now we've got 2 already, so we need 7 to go in this box here. There we go. So that's that one done. TE, we need 2. Well, we've already got 2, so again, we're going to have 0 go in that box there. N in total is 9. Well, we've got 9, so 0 in that column. E in total should be 2. We've got 2, so that's 0. This is kind of boring data, but oh well. And for T, we've got 15. And we've already got 9, so we need 6 more into the T column. And there's one person who couldn't do any of those, so they're on the outside. So that's what our finished Venn diagram should look like. Notice the outside region is people that can't do any of those. If we add this up, hopefully, what do we get? We get 16. Did only 16 people reply? Did we get 16? 7, 10, 16? Oh, I've missed somebody. Rubbish. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Who did I miss off? Did anyone clock me not mentioning their names? 10. There should be 10 people in the NE column. It was Callum. Sorry, Callum. N and T. Well, let's add you in now. So we need one more N and T. So that'll make this one up to an 8. It won't actually change anything else if I get rid of these. Cool. Well spotted, guys. Yeah, there we go. So that's a Venn diagram. So now we can ask a few questions about the Venn diagram. So what's the probability that someone can do N and E? So you get these weird symbols. The N there is not really an N, it's a union symbol. Sorry, no, it's not. It's an intersection. And it looks a bit like an N, but really it's just like a smooth N. So that means the intersection. At the moment, you guys can think of it as being and, but that's not strictly speaking always true. So we want to find the probability of N intersection E. N and E. Can anyone tell me what this probability is going to be then? Looking at this Venn diagram. Probability of N and E. Any ideas? So our total sample space is all of you, and there were, did I say 19 of you? 17 of you? So it needs to be out of 17. What's the probability someone can flare the nostrils and wiggle their ears? 2, yeah, well done, Jake. 2 out of 19, because there's 2 people in the middle that can do both those things, out of a total of 17. So 2 out of 17. Yeah, it's not 19 because I said the wrong number. Cool. Okay, so that's what an intersection is. Union gets a bit harder. So we have probability of N or E. This isn't going to work very well, but that's fine. So U there is what I said just now. This is a union symbol. Just like this. It's not really a U, but we can pretend it kind of is. And it kind of means or. Kind of. Not always. A lot of the time it means or. So we want probability of N or E. And again, the sample space is still going to be 17. So what's the probability of N or E? Any ideas? Good job, Harry. So yeah, 10. So N or E is going to be anybody in the N circle. So that's 10. Plus anybody in the E circle. Well, we've already included those 2 in the middle, so that's still going to be 10. So you get 10 out of 17 for that one. Cool. Right, next question. I imagine some of you will get wrong. Can you all try this one though? Waiting for this to catch up with me. Come on. There you go, cool. So the last one I want you guys to try is the probability someone can flare their nostrils based on this Venn diagram. And it's still going to be sample space of 17. So what's the probability then? Actually, no. Sorry, let's change that. I want to do E instead. Probability of E. So what's the probability someone can wiggle their ears out of you lot? So have a think and then type your responses. Cool, George, Billy, yep, I agree. It is 2 out of 17, so it's the 2 in the middle, 2 who could do all 3. That's probability of E. So 2 out of 17. Cool. That's the basics behind Venn diagrams. So we've drawn our own. We're now going to try and have a look at shading some areas. This is going to be hard. Normally I would get you guys to do this on whiteboards, but I can't see how that's going to be possible. We're just gonna have to go through this. So we're gonna try and label all of these regions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different sets of regions to try and shade. No, that's what we'll do. I want you guys to guess. So I'm gonna number. We'll play a little guessing game. Let's number all these things then. So we got number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is good. So I'm going to shade in this Venn diagram. And I want you guys to basically see who can get it first, which one of these probabilities is it. So looking at the probability, let's get rid of that. So the probability of each of these things. And I'd like you guys to try and copy these down as well. So I'll do one as an example. I'm going to shade in all of this area here. And this one doesn't count. You're not getting any points for this one. Which area do you guys think I have shaded? So which number have I shaded by shading all that in? So have a quick think, comment your answer, but this is a test run. We're not going to play the game just yet. Daddy, nice. Look at that. So yeah, all 3 of you guys, all 4 of you guys, 5. Yeah, you've all got it. Cool, well done. So Danny would have won the first point because I have shaded in A. So we've done this one. So if you guys want to, I don't know how you want to do this, you could take a screenshot of this or you could just do a quick sketch yourselves. This is the probability of A that I've shaded. Okay, so we're going to do a points game, and whoever gets it first gets the point, and we'll add up all the points and we'll have a winner. There won't really be a prize, but we'll have a winner nonetheless. So, okay, let's undo both of those bits then. So we've done this one, so I'm not going to use A again. Let's do this time then. What am I shading in this time? So first person to correctly state that probability. What number is that? Danny again. Nice. But then Danny rescinded his answer. Oh, nice. Good, guys. There might be a bit of lag, maybe. Maybe some of you are getting this sooner. But yeah, that is A and B because it's both of them. It's a region that is part of A and also part of B. So this is A and B. So that's what I've showed it there. Probability of A and B. Cool. Right. So I'll give the point there to Danny because he was first, even though he changed his mind quite quickly. So let me undo this again. Cool. So that's A and B done as well. All right. Next one. Let's make it a little bit harder. What do you guys reckon that region is? Oh, a lovely divisive mix there. Okay, there's actually two answers for this one. So, oh, I don't know if I have to split the prize. I think, okay, Jake, you're gonna win because yes, it is 7. This is not A and not B. The region is not A and it is also not B. But it's also A or B. It's not A or B. So 7 and 14 were correct. So Jake, you got it right, and so did Becky. I think you guys. So there's actually 2 of the ones I've put on this list there. Ah, I need to undo all this first. Cool. So that's those 2 taken up. Good. Nicely done. Let's try another one. Let's do. Where's this region? Nice, Callum. Yep, very fast there. So yeah, that is the probability of B. Good. So I've done that one as well. Cool, good. Okay, how about this bit? What region is that? Danny, you're the first one. No one else has got it right yet. Interesting. Okay. A lot of you gone for 12, A or not B. Becky's gone for 11, A and not B, yeah. So it is indeed A and not B. Okay, this region is A, but it's not all of A. We've said it's A and not B, so we're not allowed to include the bit that's also B. So yeah, it should have been 11, so that's another point for Becky. That's 2 there. Good. So that was 11. Okay. Let's try. What is this region? Who's going to get it? Danny in there rapidly. Yes, that is 2. Hopefully in a minute I'll be able to explain. Some of you are getting them wrong. I'll hopefully be able to explain why in a second. But yeah, so Danny, that is A or B. We've shaded in all of A, or it can be B. So we've shaded in all of B as well. So that's how these work. Okay, so that was A or B. Okay, let's make it a little bit harder. What am I shading this time? Nice, George. That was quick. Yep, this is not A. So I've shaded in everything apart from the circle of A. So there's probability of not A. Good. So that was George first there. Good. All right. Oh, we're only left with some hard ones now, though. Take time with this one. I wouldn't rush. I think otherwise you'll get it wrong. What do you guys think this one is? Oof. Okay, yeah, a few right answers there. So if we look, it's not A or it's B. So I'll just write this one down. Not A or it's B. And how this works is you shade in everything that isn't A, but then you are allowed to shade in everything that's B. You can do that or you can do that. So shade in everything that's A, shade in everything that's not A, and then shade in anything that's B. So I'll just show you that one again, how I kind of went through it. So shade in everything that isn't A. Well, this isn't A. This isn't A. Everything else is A though. Okay, now I'm going to shade in everything that's B because it's A, not A or B. So this bit here in the middle is B. So shade that, and that's how we got to that result. So that is not A or B. Cool. Um, let's try this one. What do you guys reckon this one is? Nice. Like it. Everyone's right so far. Lovely mix as well. Okay, yeah, so half of you have gone for not A or not B. And half of you have gone for not of A and B. So you've negated A and B. Yeah, and it can be either of these. I think normally you'd think about it in terms of the first one, but you could think about it in terms of the second one. So if I just go through how I thought my way through it. Oops, so got rid of something else we did there. So I thought not A or not B. So I started off shading everything that wasn't A. So this bit outside isn't A. This bit isn't A. The rest is all A, okay? Now I'm going to shade in the bits that are not B. Well, this bit here is not B. So it let me shade in everything apart from the middle region. So that's where that one came from. Okay, we're getting close to the end. So there's only 3 left it could be. What's this bit going to be? I think J's the first one then. Nice one, Jay. Yeah, the rest of you are realizing. Cool. Okay, some of you went for not B. It can't be that though because the middle bit is shaded and the middle bit is B, so it's definitely not B. Yeah, so it's A or not B. We'll go through Y quickly. So yeah, A or not B. So we're shading all of A. Wait, have I done something wrong here? 12. Yeah, I'm being an idiot. Yeah, A or not B. Shading all of A or not B. So shading all the outside as well because the outside isn't B. So that was A or not B. All right, last guess now, I guess, because the other one's gonna be obvious. What do you guys reckon? Yep, nice one, Danny. Not A and B. Shaded all the bits that are not A, but also being B. So do you guys kind of spot the difference between these two statements now? And then the last one, not B. Not B would just be everything other than B. Not B. Yeah, good. All right, so Danny wins. Well done, Danny. So yeah, just to talk you guys through it, because that's all the possibilities, but I don't want you to memorize them. You need to be able to just kind of spot it and understand it. So union, so A or B, A and B. Union can be one or the other or both. Intersection must be both. That's the difference in words. So one can be one or the other or both. A and B has to be both. Cool. Right, there's a little bit left to do today. Which is just come up with the equation. So there's an equation for A or B. We call this the addition rule of probability. So addition. And it's the equation that basically tells us how to find all of this area. And the rule is this. I'll give it to you guys and we'll see if you can explain it in a minute. A or B is A plus B minus A intersection B. I might write that all in a line actually, so you don't get half of it at the end. So A or B is A plus B minus A and B. Look at that. Cool. And I can show you that in kind of pictures. So A or B, which is what we were just trying to work out, the whole thing, is A, which is just the A circle, plus B, which is just the B circle. I'm running out of room. This is annoying. Let's just do this all again so you can actually see what's going on. Addition rule. So addition rule says this: A or B is A plus B minus P, A, and B. And just so you guys can see where this comes from, I'm going to draw 4 Venn diagrams. So the whole figure of 8 thing, A and B, the whole thing there, is A, which is the first circle, including the middle, plus B, which is the second circle, including the middle, minus the middle. And you can see why that is. If we add A and B together, we've actually included the middle bit twice, so we need to take away the middle bit. So that's what we get for our addition rule. Is that equation there. Cool. I think I'm going to leave it at that for today, guys. I've got a question to try, but I don't think we're going to get into this today. So I'll put a start here. Hopefully we can get this done on Friday. If not, we might have 1 lecture next week on probability and only 2 of revision. But yeah, you guys should be revising for those for that exam. It's gonna be a 2-hour exam. Use Moodle. Use your assignments you've done so far. It's just gonna be on pure. So go over all the pure stuff you've done. You guys are pretty good at pure. You've had good results in the test so far this year. I'm pretty confident with you. But obviously you probably haven't done much pure in a while, unless as you ought to have been revising. So there's past papers up on Moodle. I will show you where they are now, just so you guys can go on and practice, because you ought to be revising for this as if it's your real exam. If you fail this, you have to do a retake. So you want to get it right the first time round and make things lots easier. So if you look here, we say after week 35, there's past papers by topic. So that can be quite useful. That's this one here. Which has past papers for all these different maths topics. So that's quite useful. Even more useful, though, is the past papers and revision pure, the one after it. So this has a load of past papers. And I'll put up the 2018 paper because that's at the moment that's hidden. So yeah, there's all these papers for you guys to practice. I would try and get through as many of them as you can. Also, a year ago, I made this big AS pure paper, which is a massive past paper. You see, it's 230, basically 4 hours worth of past paper. I would definitely advise working your way through that at some point. Just as a really nice way to cover everything. But yeah, if you guys can start working through these, all the mark schemes are there as well. And just email me if you need any help. We can do one-to-one sessions on Google Classroom, but you need to start doing these as soon as possible. And I know you've got work on in your assignments as well, but you want to be revised for those exams coming up. Cool. Anyone got any questions? Because that's it for today. It looks like a no, but we'll see. Cool. All right. Well, see you on. We'll speak to you on Friday, guys. Yeah. See you then. Cheers. Bye.